Assalamu alaikum.
Welcome, Salam.
Okay, so we had a little portion of chemistry left. Let's just finish it real quick and then we'll switch to mathematics. And another thing, is there
Hmm.
any possibility that you could provide me the digital copies of physics and chemistry books also? The one,
Okay, here's the thing. With the get when once you get the textbooks, there will be a code and you'll write the code into the website and the website will make a digital copy, right?
yes.
Here's the thing. Because I'm the fourth user of the textbooks and
Mm,
there are three codes,
mm.
I cannot access those codes. So, I asked the teachers and they're trying to get a different code for me, but
Okay,
that'll be given to me by the end of this week or next week.
okay, no worries. Okay, all right, that's fine. Okay, okay, so what we were studying was heat energy. I mean the things like bond energy and what would be the internal energy, and based on the differences between bond energy and internal energy, we can understand what's an exothermic reaction and what is an endothermic reaction. And in case of exothermic reactions, heat will be released, and in case of endothermic reactions, heat will be absorbed. And based on some formulas, we learned how to calculate the energies of any particular reaction. Okay, and in your book we just see a particular really easy math. Actually we did some difficult ones as well, but whatever is part of your syllabus we will just focus on that. So what is the specific heat capacity? Okay, so specific heat capacity of a substance is the amount of energy in joules that is required in order to increase the temperature of 1 gram of a substance by 1 degree Celsius. What that means is that, for instance, X is a substance. Okay, X could be any substance. Okay, X could be any substance. Okay, now you are willing to say this is at, say, for instance, 33 degrees centigrade. Okay, now you are willing to increase its temperature by 1 degree centigrade. That means you are trying to make it 34 degrees centigrade. Okay. Now it cannot just like I mean easily or by itself increase its temperature. You have to provide heat because of that. Okay. To increase the temperature, you will have to provide heat. Okay. So and obviously this has to be of 1 grams. Okay, 1 gram. Okay, the substance has to be of 1 gram. Now the amount of heat that is needed to increase the temperature from 33 to 34, or like increase the temperature by 1 degree Celsius of a 1 gram substance, that will be called specific heat capacity of that particular substance of 1 gram. Okay. If I give you another example, say for instance, they have said that water specific heat capacity is 4.18 joule per gram degree Celsius or degree centigrade. What this means is that, say for instance, this is a container and here you have 1 gram of water. Okay, 1 gram H2O. Now, say its temperature is, for instance, say 25 degrees centigrade, and you are willing to increase it to 26 degrees centigrade. The amount of heat needed for that would be 4.18 joules. Understand my point? The amount of heat needed for that will be 4.18 joules. Okay. Right. That is what specific heat capacity implies or it means. Okay.
Okay.
All right. In case of ethanol, say for instance, if you give me an explanation to this, say for instance, they are saying aluminium specific heat capacity is 0.90 joule per gram degree Celsius. What does this mean?
Sorry.
Aluminium specific heat capacity is 0.9 joule per gram degree Celsius or centigrade. What does it mean?
So it would take 0.90 joules
Yes,
of a gram to increase the temperature by 1 degree.
1 degree Celsius. Okay, all right. So 0.9 joules of heat energy will be needed to increase the temperature of 1 gram aluminium by 1 degree centigrade. Okay. So see, this is like really easy thing, and I don't think you have any maths like we used to get maths like, say for instance, I have got say a particular temperature, say the maths were like this, say 30 degrees centigrade, 2 kg water is mixed with say for instance mm, is mixed with 50 degrees centigrade 1 kg alcohol. Okay, now you are asked to calculate the temperature of the mixture. Okay, so that was in our syllabus. However, you might get it in 11th or 12th standard maybe. It's actually not that much of important, because I mean, what is the use of it actually in real life? It's not that much of use, but in case you are working in a chemistry laboratory or physics laboratory, that is needed. But other than that, it's not that much of an use. All right. So this is the formula you will be using. So it is Q equals to C multiplied by M delta theta. M is the mass of that particular substance. Del T is the difference in temperature. Okay, difference in temperature. And C is the specific heat, which will obviously be given. Okay, you don't have to memorize it.
So mass is in grams, right?
Yes, mass is in gram. If the
Okay.
specific heat capacity is given in joule per gram degree centigrade. But in our curriculum, the specific heat used to be given in joule per kg degree centigrade. And also the mass was given in kg as well. Okay. It, it depends on what is the unit of specific heat. Okay. Understand my point?
Yes.
Okay, good. Okay, now let's see. Calculate the heat energy in kilojoules needed to increase the temperature of 100 gram water by 22 degrees centigrade. Okay. And it's a very easy. So del T equals to 22. Okay, another point here I would like to make, although you won't be needing it, that is, if there is given, say for instance, if you were working with like particular different mixtures, say for instance, water is mixed with alcohol, okay, mixed with alcohol, say like this, okay. In that scenario, you will have to consider the temperature change of water and temperature change of alcohol as well. Okay. And in those scenarios, for instance, say if they would have given us the temperature of the mixture, then we would have calculated by ourselves. Or in the other case, we would have taken the temperature as say X Kelvin. Why did I say Kelvin? See, joules, kilograms, these are SI units. Okay. And whenever you are working with temperatures as well, we are working with Kelvin. Now you might as well ask by like they have worked with 22 degrees Celsius and it's not causing any problems. Now, if I ask you why isn't it causing any problems, what do you think would be the answer? Do you have
Because it's easier to work with rather than
No, actually it's not the answer. Okay, see if you consider a Celsius scale, what is the what is it called? It's the boiling point, right? What is the boiling point? 0 degrees centigrade, right?
100. Oh,
Sorry.
yeah, because
Yes,
Kelvin is to work with
it's the
atoms.
melting point. Sorry, it's a melting point. Okay, my bad. And the boiling point would be 100 degrees centigrade. Okay. In case of a Kelvin scale, the boiling. Sorry for the bad thermometer. Okay.
That
So
is a thermometer. Wait, what? Okay.
melting point is 273 Kelvin, and the boiling point is 373 Kelvin. Now notice, whenever I'm saying that the temperature of water is increasing from 50 degrees centigrade to 60 degrees centigrade, okay. Now what does it imply? The increase of temperature is 10 degrees Celsius, right? That is what we need, the delta T, okay. Is it correct?
Yes.
And say for instance, if I want to convert 50 to Kelvin, what will it give us? It will give us 50 plus 273, that is 323 Kelvin. Okay. And 60 degrees Celsius means 333 Kelvin. Okay. All right.
Yes.
So what is the difference? Difference is 10 Kelvin. Difference is 10 Kelvin. So the difference in temperature is the same, even if you calculate the temperatures in the centigrade scale or in Kelvin scale. Okay. That is why it is not a much of a problem. Okay. That is why they are being able to use it. Otherwise, it would have given us the wrong answer. But I don't think they have given any maths like for mixtures or something. So whatever math is given to you, they will give you that. I mean, say temperature change, that is 22. The amount of, not amount, actually mass of the particular substance, and the specific heat capacity will also be given. So you have to just plug in the values and multiply them to get the answer. Okay.
Okay.
Is it understandable?
Understood.
Okay. Very good. Let's see the next page. I think that's about it. I don't think there is anything else. Okay. You might as well be asked to calculate the mass. Okay. You might as well be asked to calculate the specific heat capacity, but you have to work with only one equation. Okay. Okay. So what? Analysis of the results on the effect of an increase in temperature of water from 50 degrees Celsius to 5 degrees Celsius to inverse relationship. Oh, okay. Okay. So it's like a practical actually. So in that particular experiment or practical, you were asked to see the change in pH of water based on the increase or decrease of temperature. Okay. So that is what they have done and showed you the conclusion. Okay. So they have increased the temperature from 5 to 40 degrees Celsius, and based on that, they have seen that the pH has decreased from 7.4 to 6.8. Okay. So from that, we can understand that if we increase the temperature of water, the pH will be decreased. Okay.
Okay.
That's about it. I guess I don't see anything else. And in even in our curriculum, actually, when we studied, I was in 10th and 9th standard around 2015. Uh, the calorimetry or the maths of calorimetry were obsolete by then. Actually, we were not doing those maths, but as it was part of the like previous curriculum, I myself, not actually only myself, actually, we read at a particular private tutor's house. So he also suggested that we should do those maths. So that is why we did it. Okay. So I don't think you will be needing it.
Okay.
Let's start mathematics. Okay. So mathematics, tell me, from where should I start? Okay. Just give me a second.
Do you want to pick specialist, methods, or general?
Okay. Just give me a minute. Okay.
Okay.
Okay, sorry about that. Yes, so as I was asking, so where should we start mathematics?
Do you like specialist methods or general?
Anything, the one you would ask me to. Okay, because I don't have your syllabus, so I don't know which chapters will be studied at
Okay.
your school. Because as you said that all of the chapters won't be studied. Okay.
Okay. Well, all the chapters will be studied from like in order. So for specialists, we did some set theory as well as factorials and permutations.
Mhm.
That's for specialists. Methods, we're doing arithmetic sequences. So like what's the 19th term of this pattern? And there's formulas for that. And for
Mm.
general, we are doing rates, like money-based stuff, financial
Okay.
maths.
So so we have to. It's better if we study a particular chapter's general maths portion first, and then we go towards the special maths, right?
Yes, but there's also something to keep in mind with
Yes.
these maths. It's
Yes.
not that general maths is worse than special maths. Every single maths has like a different kind of section that they cover.
Okay.
So there might be some sections that specialists cover, but not general, but general might cover stuff that specialist doesn't. It's
All right.
yeah,
So some things could be excluded in the specialist mathematics, and some could be excluded in general mathematics. Okay.
yes.
Okay. Consumer arithmetic. Okay. Let's start from here. This is how your school also goes, right? Like serially. Is it correct?
Yes.
Are you confused with that?
Yes.
Okay.
A bit.
I think it should work like that, and it's a very easy chapter. Let's see how we'll try to go fast with this. Okay, so introduction. You will study introduction. Let's see the definition. Okay. So first of all, we will work with rates and percentages. Okay. The percentage is a fraction which involves the denominator of 100, right? And
Yes.
rates are usually, seen with like percentages or maybe anything else. Okay. So let's see definition of rates. Rates and percentages are used to compare how different quantities change. Rates compare quantities of different units of measurement, and percentage represent a portion out of 100. Okay, as we said, rates compare quantities of different units. Okay, so if I give you an example, say for instance, say James is moving at a rate of say 5 kilometers per hour, and say any other name. Okay, say for instance, X is moving at a speed rate of 10 kilometers per hour. So with the speed rates, we can understand that X is moving faster than James. Okay, all right. And if we compare the ratio, say for instance, how fast is James sorry, X moving than X based on 100 kilometers per hour. So then we will get the percentages. Okay, so like in this way, we can calculate rates and percentages. So a rate is a measure of change between two variables of different units. Okay. So a rate is calculated per unit or per item. Common examples of rates include speed in kilometers per hour or meters per second, costs and charges in dollars per hour, electricity used in kilowatts per hour, like that. Okay. All right. So based on time, we are seeing in most cases, we are calculating rates. Okay, see, kilometers per hour based on time, meters per second, dollars per hour. I am not saying that it has to be the case all the time, but usually rates are calculated based on time. Okay. All right. Just tell me, what is it's like a very piece of cake math. Tell me, 4.3
Oh,
kilometers in 24 minutes. What will be the rate of speed, kilometers per hour in kilometers per hour? Tell me, tell me.
wait, hold up. I'm having a mind blank right now. What is going on? Okay, hold up.
Are you okay?
No.
Yeah, have a sip of water actually.
10.75 kilometers per hour,
Okay, yes,
I think.
answer is correct. But are you feeling okay? I mean, are you feeling sick or something?
Yeah, I'm okay. I just like looked at the question for a good
Okay.
uh 20 hours. That's what I thought.
Okay, that's better.
Ooh, guess what? I got my first graphics calculator.
What? Graphics what?
My first graphics calculator.
What is a graphics calculator? I mean, will you be able to see the graphs in a calculator? Is it so?
Pretty much. Graphics calculator is just like a lot more than a scientific calculator. It's like a
Understand,
lot
but
more
should
advanced.
it be given to students? I
What do you
mean,
mean?
because I think that students should be able to realize what should be the graph based on seeing the equation. That is what I think. Okay.
Yeah, no, but this has a lot more than graphics calculator. Like these calculators do a lot more. For example, run matrix statistics,
Yeah,
spreadsheets,
yes,
recursion.
it's okay. I mean, we also were able to like do
It's
metrics
got
and
Python.
statistics. But if we were not allowed to use those calculators, which would like show us the graph, because it makes things a lot easier and it might actually lower the potential of students. Okay, say for instance, if I give you a graph, 5x plus 7. Okay, so based on that, we we are, I mean, experienced to such extent. We see how many seconds do I take. 1 2 3 4, say this is 7 units. Okay, 7 units, and then based on that I will just cut a line. Okay, see, this will be our graph for 2x plus 7. Okay, this is because we were not used to the calculator, so we had to, I mean, experiment, or like, what can I say, practice on our own. Okay, so how did I get it? See, 2 will be our I mean, gradient or slope, so it's not that much of an issue. And we can understand it will be upward sloping. Why? Because the sign is positive. Okay, and 7 is the unit that will be cut from the y-axis, positive y-axis, because this is given like +7. Okay, understand my point? So this is how I mean, we experienced or like learned the things. Okay, now if you are given a graphics calculator, will you like bother to understand these things? You are just can easily type down y equal to twice x plus
But
7. You will get the
yeah,
answer.
that's the thing. They expect us to already know what these things are, so why have the trouble of doing something, working something out for so long, even though you know it, then just give you a calculator.
uh, I mean, I understand your point,
Mm,
but
mm.
isn't there
Yeah,
a
that's
possibility that students won't use their 100% potential if a calculator is doing all the things? Okay. Say for
this is
instance, if you were given a calculator at standard 1 or 2, will you be keen to learn how multiplication or addition works? You would be just doing, like, say for instance, 14, then plus sign and 7. Okay, then you would
that
get the
separates
answer.
me from all the other puny humans, so I am curious.
Okay. All right. Obviously, use the graphics calculator to your fullest to, I mean, save time in time and energy in the examination hall. But what I'm saying is you should also be accustomed to using or drawing the graphs in hand without any graph paper and without graphics calculator. So it's easy.
Okay,
I mean, it's no problem in knowing that, right? Right, it's a skill to have it. You agree with me on that point, right? That it's a
mostly.
brain skill. All right, the next one, very easy, 11.5 divided by 12 upon 60. Okay.
Yeah.
James Watt says a barista. What is barista? Is it like a chef or something? Based on the
And barista is pretty much just a coffee maker.
Oh, okay, all right.
I'm actually a barista as well.
Okay.
I'm
Do you
very
make
skim
coffees or
milk.
something, or do you are you
Yes, I do.
involved in? Okay, that's good.
The milk is very scary.
Actually, in our country, there are also students who are involved in part-time jobs in cafes as waiter or
That's
waitresses.
nice.
Mostly waiters, because ours is a conservative country, so they
Yeah.
don't particularly like females working like serving
Oh,
things. But if
feminism
you
at its
see,
finest.
if you see in another way, they would be happy if a wife serves to the guests arriving at home. Okay, whatever. So, what was I saying? Okay, so they don't give the jobs of like coffee making or as chefs to the students. Okay, but
Oh,
there
okay.
I have seen students who would like buy their caravan, not caravan actually, you could say food cart actually.
Yeah.
They would buy their or make their food cart and like sell hot dogs or burgers or make their
That's
popcorn.
so cool.
That's cool, yes. But I mean, it's a very risky thing to do as well. But because if you fail in your business, so that's a loss.
Yeah, it's a big risk. Yeah.
And also, you have to maintain your studies as well, right? While doing this. So,
Yeah,
all right.
that's true.
But the thing you see, like I'm teaching you, this is very, very, very popular in our country. Like, and I guess 90% of the university going students are involved in tuition, at least the males. That is what I can confirm you. I don't know about the
Oh, okay.
females, but the males are, and even females do I mean teach the students as well, but not at this high percentage. Okay, enough said about these. Okay, so $99 for 1 hour, you have to calculate for per hour, so you have to just divide by 6. Okay, why are we studying this at like this level? Okay, see, percent means per
169.
100. Okay, per cent. Okay, so since if you were like residing in Britain, maybe they use the term cent, right? Like this is like 20 cents, water is 50 cents, something like that. Okay, so cents mean like 100. Okay, and also you are used to cricket, I guess, so we also call our term century, right? Century has also come from the term cents. Okay? Century means scoring 100. Okay, so this has also come from cents. Okay, cents. Okay, however, so a percentage means out of 100. So why is it out of 100? See, 50 upon 100. Okay, so how will you represent it? You will see 50 out of 100. 50 out of 100. That will be our interpretation. Okay, so for instance, if a particular student has gotten 97% marks, we will say that he has got 97 out of 100. 97 out of 100. Okay, so this is how we interpret. Like these are schoolboy things, but as the topics are coming, that is why I'm saying one or two things about them. Okay, percentages are used in many everyday applications, including sales, commission, profits, and okay. Consider the situation of reducing the price of an item by 18% when it would normally sell for 500. Okay, so a reduction of 18%, that means you will just have to multiply this base price by 18%. And what does 18% imply? Always remember, whenever you see a percent sign, you have to just divide by 100. Okay? Maybe you know it. Okay, 18 by 100. Okay,
Yes.
any percent. Okay, even if it's like say 125%, what you will do is just 125 by 100. Just divide by 100. That is the significance of this particular symbol, which is the percent. Okay. All right. So
Okay.
the reduced selling price can be found by evaluating the amount of the reduction and then subtracting it from the original value. Okay. So $90 would be our reduction, and then we can reduce it to get $410. Okay. All right. And if it say that it could be said like discounted price. Okay. So that term could also be used. Say for instance, if a particular shop is saying that 10% flat discount. Okay, what does 10% flat discount mean? What do you think it means?
Um, just a discount. Yes.
Yes, it's a discount. Say for instance, a particular shop holds say 1000 kind of products. Okay, so in case of 10% flat discount, it means that your discount will be gotten for all kinds of products. Okay, anything you buy, no matter what is the price, no matter what is the product, you will get a 10% discount. Okay, but some shops say that 20 up to 20% discount, up to 20% discount. Okay, so this is a marketing strategy actually. So based on that, whenever you will see a particular, let's say, signboard saying that up to 20% discount, you will obviously feel keen to entering that particular shopping mall. Okay, but you will find that whichever product is giving you 20% discount, that is not particularly attractive, that is not like what can I say, you don't like it or something. Okay, so those are the products they are providing 20% discount, and the ones that are like very good and very attractive, very well polished, they are giving 2% discount. Okay, see the term up to. Okay, they are correct. Okay, up to 20% discount, you might get 2 or 3 products which have 20% discount, but most of them might be 2 to 3% discount. Okay, understand my point? So this is the difference between flat discount and up to discount actually. Okay, all right, I don't know if you get maths on these. We will see. Okay, to reduce something by say X%, multiply by 100 minus X%. Okay, so you can also do that. Like if the reduction is 18%, that means the price will be 82% of the previous time. Okay, understand my point? Say if we do like 18% reduction, that means the price afterwards will be 82% of that of the previous price. So 82% multiplied by 500. Okay, so that will be 82 upon 100 multiplied by 500. So that will be 82 multiplied by 5, which is 410. 410. Okay, so we are getting the same value. Okay, whichever way you do it. Okay, whichever way you feel preferable, you could find the reduced price and then deduct it from the original price, or maybe you can calculate it directly. Okay, calculate an increase to $76 by 15%. Okay, so you can calculate in 2 ways. One would be like 15 by 100 multiplied by 76. Okay, this plus 76, or you could do is 115 by 100 into 76, whichever way you feel comfortable. Okay, I'm going a little fast. I hope it's understandable because the things are like really easy.
Yeah, very easy.
Sarah bought a car for $7,500, sold it 4 years later at a discount of 30%. See the discount. Okay, discount. Okay, calculate how much she sold the car for. So you can calculate for 70% multiplied by 7,500. Okay, so yeah, that is it. You will get the answer. Okay, let's see what have they done. So okay, say they have calculated based on 100 plus 15 equals to 115%, and also here they have just done it real quick by subtracting or adding the percentages increase or decrease. Okay, all right, so percentage increase or decrease, amount of increase or decrease divided by the original amount multiplied by 100. Easily understandable, like just multiplying it with 100 divided by the original amount. We will see based on the what can I say, the maths. Okay, Raymond bought a laptop in a sale for $774.40. If the original price was $968, calculate the percentage discount. First of all, what you need to understand is he has bought the calculator for $774 and the original price was $968. Okay, so what is the amount of discount, or what is the amount of reduction? Okay, so that will be 968 So the amount of discount equals to 968 minus 774.4. Okay, so based on that you will get something. Okay, now you have got the decreasing amount. Okay, but it has been calculated based on 968, right? Okay, so that does not give us the percentage value. So to get the percentage value, we have to divide by 968 and multiply it with 100. Okay, and you will see a lot lesser value than this is, because obviously if the original price was $100, then the discount won't be that much high. You can obviously understand that, right?
Yes.
Okay, that's my point. Okay, let's see. So as you can see, $193.6 was a discount, and then they have divided it with the original amount, which is 968, and multiplied with 100. Okay, they have got a very round figure, which is 20. So they have provided a 20% discount. Okay, understand?
Yes.
Okay, let me give you another link.